All right, guys, I'm going to try to get this done in hopefully two sections, but it might take me three. Starting off, core case study, mercury's toxic effects. We saw the video today, so hopefully that gave you a pretty good idea of mercury. Biggest things to remember: two-thirds of what ends up in the atmosphere is a result of human actions. Greatest risk is it causes neurological damage, specifically in fetus and younger children because they are still developing. Most common ways that we get it into our systems: fish contaminated with mercury, inhalation of vaporized mercury, and it does biologically accumulate, so it increases as it makes its way up the food chain. There are certain species of fish, those that typically live longer, eat more, that are more prone to absorb mercury from the environment. All right, so we're going to move forward to the major hazards. Before that, make sure you understand the difference between risk assessment, and risk management. Risk, probability of suffering harm from a hazard. One of the big things is we a lot of times misjudge risk. So risk assessment is really important to provide data, statistics, so that we really truly understand what the risk or potential for harm is. Risk management, a lot of times this comes into play into big businesses, schools, that type of stuff, where you're trying to reduce particular risks to avoid injury, to avoid all kinds of other things as well. All right, types of hazards. There are four main ones, and the fourth is down here, but biological, pretty straightforward: anything living; chemical, any harmful chemicals; natural, these typically are things that we would consider natural disasters or physical hazards. They are also referred to as cultural, just things we're exposed to because of the line of work we're in, because of the country we grow up in. The environment that we belong to really dictates a lot of cultural. And then this last one, I don't know that it's necessarily a hazard, it's just based on the decisions that you personally make. So biological hazards, it's important that you understand a little bit about each of the different types or categories that are presented in this particular chapter. So viral versus bacterial versus something from a living organism, a parasite. In the case of malaria, we looked at a protozoan. Infectious disease, pathogen that invades the body, multiplies: viruses, bacteria, parasites. We'll look at one example of each of those. Transmissible is something that can be passed from person to person. Various forms of transmission of those diseases. I gave you guys a little handout that shared a little bit on how each of a set of infectious diseases can be actually passed on. Non-transmissible, things that basically there's not something like a virus or a bacteria, protist, something like that causes it. These are things that we maybe develop over time or may result as because of a genetic predisposition, something like that. Epidemic is large-scale outbreak. Pandemic is when it goes global. So anytime there's an emerging infectious disease in particular, which things like we saw the video on Ebola, the whole goal is to avoid these types of things, epidemics and pandemics. So they try to get ahead of it and cut it off before it can spread too far. I think I had you guys at least write these down in order. You don't have to remember the numbers, but deadliest things, this is what the book presents. I've seen different data that suggests maybe the flu virus is not the most deadly. However, for our purposes, make sure you know that the influenza virus is the most deadly. HIV and AIDS, diarrheal diseases, cholera, dysentery. Tuberculosis is a bacteria, malaria, which is a protozoan, and then you have hepatitis B and measles. Be familiar with that list. All right, tuberculosis, sorry for that one. 1.4 million deaths each year, primarily in less developed countries, just because of the inability to detect, treat, and sustain people who become infected. It's really a result of a cultural poverty that exists and not having the necessary things to combat the disease. This is your example of a bacterial disease. You can also see genetic resistance to a majority of effective antibiotics. That's a key to telling you that it is a bacterial infection. It's a disease that affects the lungs. Basically what this is just showing is these areas are areas where there's some major lung tissue damage. Areas where you see higher incidence, you can see the less developed regions, tropical regions. Not that it's a tropical disease, however, a lot of the less developed countries happen to exist in this particular area or portion of the earth. Viral diseases, these are the big ones to be familiar with. I think in your notes I added Ebola as well, but influenza or the flu virus, HIV, hepatitis B, and then emergent diseases like West Nile, Ebola, avian flu, that type of stuff. How do you reduce your chances of infection? I think that I cut this out of your notes, but some of the simple ones: wash your hands, avoid touching your face. It's an easy access into your body, through your nose, through your mouth. HIV. HIV is the virus. AIDS is the disease, and AIDS, when it does develop from HIV, typically results in an immune system breakdown and people being unable to fight off other diseases. So while HIV does compromise a system, typically death results from complications with some other sort of illness like pneumonia. We're very aware of HIV and AIDS and the threat that it poses. Most prevalent sub-Saharan Africa, simply because lack of education, high levels of prostitution, and either lack of or unwillingness to use protection, specifically the males, unwilling to compromise with that. And the biggest problem is it devastates the strong, those in the reproductive age, which are really the ones that are going to work and supporting that population. So it leaves a lot of orphaned or single-parent children in those situations. Our parasite example is malaria, caused by a parasite. Specifically, it's a protozoan Plasmodium. This is a tropical and subtropical disease. It is not something that spreads person to person, I guess technically, but it has to be carried by a vector mosquito, specifically a species called Anopheles, that bites an infected person, picks that up in their blood, and then can transfer it to somebody else. There is the potential threat of diseases like malaria spreading further north due to climate change. Malaria is on the rise. Plasmodium is becoming a little more resistant to drugs. The insecticides that we're using, mosquitoes are becoming more resistant. That's why sometimes they'll still use DDT, which is nasty for the environment and potentially for people. But it's that serious of a disease that they will use things like that to protect human life. Again, these are regions where malaria exists. Doesn't quite make it to us. Good news about disease is percentage of deaths resulting from infectious disease is coming down. That tells you that health and nutrition is getting a little bit better. Access to clean water is getting a little bit better. More people are in urban areas where you do potentially have access to decent medical facilities, vaccinations, those kinds of things. Bad news is developing countries are still pretty far behind in terms of taking care of and handling these types of things. This is a table in your guys' book.